Next problem is verify whether the random process x of t is equal to y sin omega t is WSS or not, where this y is uniformly distributed in the interval minus 1 comma 1. So you are supposed to verify whether it is WSS process or not. For that we know that this mean value must be a constant and autocorrelation function must be a time difference alone. So let us verify it. The first thing, we will find out the probability function. Here y is the variable which is uniformly distributed. So f y of y is equal to, we know that how to calculate the probability function, which is nothing but 1 by b minus a. Here the interval is minus 1 comma 1. So a is minus 1, b is 1. So 1 by b minus a is 1 by 1 minus of minus 1, which is equal to 2. So the probability function is 1 by 2. So the function fy of y is 1 by 2 in the interval minus 1 comma 1 under uniform distribution. Okay. Next we will go for a mean, which is expectation of x of t, which is equal to integral minus 1 to 1 x of t fy of y dy. Here in the given problem, x of t is y sin omega t, where this fy of y, since its uniform distribution, we find it out it is 1 by 2 dy. Let us take all the constant term outside. So this 1 by 2, the sin omega t as is constant, so taken out. What is remaining? Only y. When you integrate this y square by 2, and we will substitute the limit. First we will substitute the upper limit. Upper limit y square, so 1 square, so 1 by 2 minus 1 by 2. So if you take this, we will be getting it as 0. So we got the mean term as 0, which is a constant. So the first condition is satisfied for WSS process. Next we go for autocorrelation function, which is r suffix xx of t comma t plus tau, which is expectation of x of t into x of t plus tau. Okay. So what is x of t? Y sin omega t. X of t plus tau means y of sin omega in the place of t plus tau. Okay. Now there are two y. So y square sin omega t sin omega t plus tau. Okay. So if we integrate it, if we find expected value, integral minus 1 to plus 1 y square sin omega t plus tau 1 by 2 dy. So we are integrating with respect to y. Take all the rest of the terms as constant, so we are taking out. So sin omega t plus tau, this 1 by 2, all are constant terms, so we have taken out. The remaining term is y square by 2. Sorry, y square alone. So when you integrate this y square, y cube by 3, the limit is minus 1 to plus 1. Let us substitute this. They take this 1 by 3 also outside, so it becomes 1 by 6. Already 1 by 2 is there. When you multiply it with 1 by 3, it becomes 1 by 6. Okay. This term is a constant, so it is as it is. So when you substitute the limit here, 1 cube minus 1 the whole cube. Upper limit minus lower limit. So you will be getting 1 cube is 1, minus of minus 1 cube becomes plus 1. So 1 plus 1, 2. So 2, here it is 1 by 3. When you cancel this, it becomes 1 by 3. So 1 by 3 sin omega t into sin omega t plus tau. Now we will replace this, or else we will reduce this. So we know that sin A sin B. Well, actually the formula is 2 sin A sin B equal to cos A minus B minus cos A plus B. Here it looks like sin A, this is sin B. So we replace it as 1 by 2 into cos A minus B. So omega t minus omega t minus omega tau minus cos A cos omega t plus omega tau. If you simplify this, here this omega t minus omega t gets cancelled. The remaining term is minus omega tau. Here it is omega t plus omega t. So 2 omega t plus omega tau. So this is cos minus omega tau. This is cos minus theta. We know that cos minus theta is cos theta. So it becomes cos omega tau minus cos 2 omega t plus omega tau. This is the autocorrelation function. Here we can notice that it has a t term in this autocorrelation function. So we know that for autocorrelation function, for WSS process, this autocorrelation function must be dependent of tau alone, but here it is dependent of tau as well as t, so we cannot consider it. So the second rule fails, so which is not WSS process. Okay, next we go with another problem. Show that the random process x of t is equal to a sin omega t plus theta is WSS, where a and omega are constants and theta is uniformly distributed in 0, 2 pi. So we come across with two problems. Okay, so here the variable is theta and it is distributed under the interval 0, 2 pi. So the probability function is calculated as f of theta is equal to 1 by 2 pi minus 0, because uniformly distributed means 1 by b minus a. Here a is 0, b is 2 pi. So 1 by b minus a means 2 pi minus 0, which is nothing but 1 by 2 pi. See, we find out the probability value. Next, to show that it is WSS process, the first thing we have to check with mean. So mean equal to expectation of x of t, which is nothing but integral 0 to 2 pi this x of t into f theta of theta into d theta. So x of t is a cos sin omega t plus theta into f theta of theta is 1 by 2 pi d theta. Okay, now let us collect all the constant terms outside to proceed with integration. Here the integrating variable is theta. So let us have this constant a by 2 pi as constant outside. The remaining is sin omega t plus theta. When you integrate it, the sign becomes minus cos omega t plus theta and the limit is 0 to 2 pi. When we substitute the upper limit, minus cos omega t plus 2 pi plus cos omega t plus 0, which is nothing but cos omega t. Okay, now this minus cos omega t plus cos 2 pi, which is 2 pi plus theta is cos theta. Okay, so and you know that cos 2 pi value is 1. So this 2 gets cancelled, so 0, because cos omega t plus 2 pi, we know that cos 2 pi plus theta is cos theta. So this becomes minus cos omega t plus cos omega t. This is in negative term, this is a positive term, gets cancelled. So we got the mean value as 0, which is a constant. So the first condition satisfied. Next we go for autocorrelation. Autocorrelation is equal to r suffix xx of t comma t plus tau, which is nothing but expectation of x of t into x of t plus tau. X of t means a sin omega t plus theta and a sin omega t plus tau plus theta. Here two a terms are there, so a square taken out. Next is sin omega t plus theta is sin omega t plus omega tau plus theta. Now let us have it in the form sin a sin b. So cos a minus b minus cos a plus b. So a term is omega t plus t minus, this is p term, so minus omega t minus omega tau minus theta. The same thing with the plus terms. So here this omega t minus omega t plus theta minus theta cancelled. So the remaining is minus omega t. Here it is 2 omega t terms. So 2 omega t, 1 omega tau, 2 theta terms are there, so 2 theta. Okay, so this cos minus theta becomes cos theta. Here it is as it is. This a square by 2 is common to both. So it is divided into two parts. So a square by 2, expectation of cos omega tau. There is no variable term here, so it is a constant, so it is taken out. So the a square by 2, it is expectation of means integral 0 to 2 pi cos 2 omega t plus omega tau plus 2 theta 1 by 2 pi d theta. Okay, so when you take this 2 pi outside, it becomes a square by 4 pi. So this integration of cos term is sine, and we are integrating with respect to theta, so this coefficient comes in the denominator by 2. Okay, so you take this 2 out, so 8 pi. So what is the remaining term? To apply the upper limit minus lower limit. When you apply the upper limit, this becomes 4 pi. When you apply the lower limit, this becomes 0. So the remaining terms will be as it is. Now you can see here, cos 4 pi into this term is considered as theta. So sin 4 pi plus theta equal to sin theta. So sin 2 omega t plus omega tau minus sin omega t plus omega tau. This is in positive term, this is a negative quantity, so it gets cancelled. So this second part, whole terms become 0. The remaining term is a square by 2 cos omega tau, which is dependent only on tau, which is a time difference. So in this problem, mean is constant, autocorrelation depends only on tau. So we confirm that this x of t is a WSS process. Okay, next we will see a very simple problem. Given a random variable y with a characteristic function pi of omega equal to expectation of e power I omega y, and a random process defined by x of t equal to cos lambda t plus y. We are supposed to show that x of t, where t belongs to the index at t, is a WSS process, and they given the condition pi of 1 is equal to pi of 2 equal to 0. This conditions should be made use. Now let us see. Given pi of omega equal to e power I omega y, pi of 1, so omega should be replaced with 1. So when you replace expectation of e power I y, which is equal to 0, it is given in the problem. We know that e power I y is nothing but cos y plus I sin y. So expectation of cos y plus I sin y is equal to 0. When you take this expectation value inside, expectation of cos y plus I into expectation of sin y equal to 0. So we come with that expectation of cos y equal to 0, expectation of sin y equal to 0. Similarly, another condition, pi of 2 equal to expectation of e power 2iy equal to 0. This e power 2iy is cos 2y plus I sin 2y. When you take this expectation inside, expectation of cos 2y plus I into expectation of sin 2y equal to 0. So when you equate this, expectation of cos 2y is equal to 0, expectation of sin 2y equal to 0. Now we verify whether it is WSS or not. The first thing we are supposed to do is check with the mean. So mean means expectation of x of t. So expectation of what is given? It is given as cos lambda t plus y. So it is cos lambda t plus y. So it is in the form cos a plus b. So cos a cos b minus sin a sin b. Now if you take the expectation value, the variable is y here, so the expectation value is this. So cos lambda t, expectation of cos y minus sin lambda t, expectation of sin y. We already know that expectation of cos y value is 0, expectation of sin y value is 0. When you replace this, all the term gets vanished, you will be getting the value as 0, which is a constant. So the mean value of the given x of t is constant. Next we check the autocorrelation function. So autocorrelation function in the sense r suffix x of t1 comma t2, which is expectation of x of t1 comma x of t2, which is equal to expectation of cos lambda t1 plus y cos lambda t2 plus y. It is in the again in the form cos a plus cos b. So 1 by 2 into cos a plus b plus a minus cos a minus b, which is clearly mentioned here. Okay, now if you simplify this, this becomes, you can see here this cos, again cos a plus b, you can see here cos a cos b, because cos a plus b in cos a cos b minus sin a sin b. So this term alone has been changed as cos a plus b is cos a cos b minus sin a sin b. This term as it is. Now you can see this 1 by 2 we are taking this expectation value inside. So this is cos lambda t1 plus lambda t2, expectation of cos 2y minus sin lambda t1 plus lambda t2, expectation of sin 2y plus cos lambda t1 minus t2. This already we know that the expectation of cos 2y is 0 and expectation of sin 2y is 0. When you replace this, these two terms totally get vanished when it multiplied with 0. The remaining term is cos lambda t1 minus t2. So t1 minus t2 is nothing but tau, which is a time difference. So the autocorrelation function for the given term is dependent of time difference only. So we confirm that the given process is a WSS process. Similarly, we are dealing with other problems also.